The sign of a great music gig when I was in my teenage years was that I had a ringing sound in my ears and that my body was aching. I loved being right near the front where I was blasted by the huge speakers, caught up in the sway of the crowd and involved in any mosh pits that were happening. The energy from the band was tangible through how I reacted to the beats. If it got too much, I would head towards the back of the venue where I could catch my breath and didn't feel as much of the impact of the band's energy. In other words, the distance I was from the stage area directly affected the influence the music had over me. When I was close, it was powerful. When I was further away, it influenced me less. This is similar to how an electron experiences the pull of the nucleus, how attraction is affected by distance. So grab a periodic table and let's look at the chemistry. This is Thing 4. Moving across the second period in the periodic table from lithium to neon, there are three factors you are aware of. The ionization energy and the electronegativity increase, while the covalent radii decreases. This is all due to the effective nuclear charge. Within an atom, there is an electrostatic attraction between the protons in the nucleus and the surrounding electrons. Going across the aforementioned period, we notice that the number of protons increase, shown by the atomic number, while the number of energy levels is the same. This results in the electrons experiencing a greater attraction from the nucleus, known as the effective nuclear charge. With this increased pull from the nucleus, electrons will be harder to remove and are drawn closer to the nucleus. Just like me, being close to the stage where the power of the music is stronger and has a much greater influence. This explains why fluorine is the most electronegative element with 4.0 on the Pauling scale. It has a low number of energy levels while having a relatively high number of protons. This leads to fluorine being a strong oxidizing agent and being able to even form compounds with noble gases such as xenon difluoride. Let's now go down a group and study what happens to the effective nuclear charge. Going down a group increases the number of protons in the nucleus, so therefore the nuclear charge. Why is it then that the ionization energy and the electronegativity decrease? This is where we must consider the number of energy levels. As the number of energy levels increase, the outer electrons experience a lower effective nuclear charge. The electrons on the inner energy levels shield the nucleus from the outer electrons, therefore weakening the grip that the nucleus has. This explains why elements at the bottom left of the periodic table are the least electronegative and with lower first ionization energies. Just like me at a gig near the back of the crowd, with thousands of people between me and the stage, the power of the music is less, its influence on me reduced. When being asked to compare the effective nuclear charge of two elements, it is important to consider the species mentioned. For example, a positive sodium ion will have a greater effective nuclear charge than a fluorine atom. They both have the same number of energy levels, but sodium has a greater number of protons. This means the second ionization of sodium is greater than the first ionization of fluorine. It also means that the sodium ion is smaller than the fluorine atom. This electrostatic attraction between the nucleus and electrons has a major role into the structure and properties of compounds. So the next time you are in the sway of a crowd being impacted by the energy of music, imagine you are an electron and the potential you have to impact the world around you. And by the way, if you are standing so close to the stage that your ears are ringing, you are too close. Move back. This was Think 4. Thanks for watching.